Let's take a look at one last way to go ahead and solve our systems of linear quadratic equations, and that's through substitution. So remember, when we substitute, you put in y for y, x for x. So when we look at these two equations, they're already both isolated for y. So we can substitute in x squared plus 5x minus 1 in for y on the second equation. So that'll give us x squared plus 5x equals 1 equals 5x plus 3. Now we know in order to solve a quadratic, we need to get it set equal to 0. So I'm going to go ahead and subtract 5x and 3 from both sides. Everything will cancel off on the right-hand side, and that will result in x squared. We have a 5x and a negative 5x, so those will actually cancel. And then we have negative 1 minus 3, which is negative 4. So now we're left with the quadratic x squared minus 4 equals 0. So now we have to review all of our different ways to solve a quadratic. So we can factor, we can complete the square, we can use the quadratic formula. We have all of our different methods. But looking at this one, since there is no b value, and we just have the x squared, our easiest method is going to be to use square roots in our radicals. So I'm going to isolate the x squared by adding 4 to both sides. That'll result in x squared equals 0 minus 4 is negative 4. The inverse of our radical is going to be to take the square root. So that'll result in x equals, and reminder, when we take the square root, that should be a positive 4 when we added it to both sides. When we take the square root of both sides, that yields both the positive and the negative value. So we get the positive and negative value of the square root of 4. So the square root of 4 is rational, so we get positive and negative 2. Now, what this gives us is this gives us the x values, gives us the solutions to the quadratic. But we need to know that once we know what x is, we need the ordered pairs that make both true. We need both the x and the y. So we have the x's, now we need to substitute them back in to find our y values. Now we can plug them back into any of the two equations. I'm going to go ahead and go with the linear. I feel like it gives us a little few less steps. So the first thing I'm going to do is I'm going to plug in when x equals 2. So y equals, substitute 2 in for our x. So 5 times 2 is 10, and 10 plus 3 is 13. So y equals 13. So that indicates our first ordered pair would be 2, 13. There's our first solution. Now let's plug in negative 2 and see what we get for y. So y equals 5 times negative 2 plus 3. So that would be y equals negative 10 plus 3, which is negative 7. So our second ordered pair would be negative 2, negative 7. So we have two solutions to this systems of equations, and they should make both true. So we've just seen how they make the linear equation true. Let's go ahead and check in the quadratic. If I take x squared, that would be 2 squared, which is 4, plus 5 times 2, which is 10. 4 plus 10 is 14. Subtract 1, and that does give us the y value of 13. If we plug in negative 2 to negative 7, we can prove that it works in the quadratic. Negative 2 squared is 4. 5 times negative 7, 5 times negative 2 would be negative 10. So 4 plus negative 10 would be giving negative 6. Subtract another one, and we get our y equals negative 7. So both make it true. Just make sure that once you get your x values from the original first step, that you plug those back in so you get the ordered pairs and you get your y values.